friction on the concrete surface creates a couple moment of 100 Newton meters on the blades of the trowel. So like a smoother, concrete smoother. Determine the magnitude of the couple forces so that the resultant couple moment on the trowel is 0. So here are the couple forces. The couple forces from the user, the hands of the user. The forces lie in the horizontal plane and act perpendicular to the handle of the trowel. So these couple moment example problem videos are really short. I was thinking about putting a bunch of these problems together in one video, but I decided to leave each example problem separate because I want to emphasize that couple moments, because they're free vectors, are easy to work with. It can really be that simple when you're dealing with couple moments. So you can think about this entire machine as a rigid body. So in other words, what that means is you don't have some big spring here, some big rubber attachment that's flexing because of this turning force. That would change the problem, right? It's all the connection from the floor, from the blades to the hands is all these rigid metal components. You can assume they're rigid. Okay, and then this sentence here, the forces lie in the horizontal plane and act perpendicular to the handle of the trowel. They're just trying to make it clear that the rotation axis of this moment and the moment created by the forces from the hands. So you can imagine, to hold this steady, this force is pulling back and this force is pushing forward. The axis of rotation for this moment and this moment are the same. Because yes, couples are free vectors, but if for some reason this force was down here and this force was up here, well then the plane is like, the axis of rotation of the couple moment is like here, compared to the moment of this one being here. You could still do a vector sum. It would be easy. These are free vectors, but you would have to break this up into its components as opposed to just do like a scalar sum. But because this is saying that the forces lie in the horizontal plane and act perpendicular to the handle of the trowel, the axis of rotation here is this axis. The axis of rotation here is this axis. And when it comes to the moment from the blades, that makes sense. For the most part, the forces on the blades are in the plane of the ground. So we've got a moment of 100 Newton meters from the ground on the blades. To counteract that moment and hold this trowel steady, what's the magnitude of the forces from the hands on the handle need to be? Well, they give you this distance here, but that's just to confuse you. In this problem, this distance means nothing, or we don't need it. All we're going to do is say we've got these forces separated by 750 millimeters. So these forces times 0.750, and we're not going to worry about a sign convention. This needs to be equal to, what moment is it countering? This needs to counter this moment, 100. That's it. $133.3 newtons. It's that simple. That's it. It's just a simple vector sum.